Hi students, today we are going to take our multiplication with polynomials one step further. And now we're going to take that to multiplying a binomial times a binomial. So remember, we said when we are multiplying up or doing anything with a binomial, it's something with two terms. So we'll be multiplying something with two terms times something else with two terms. Now, this goes back to the exact idea that we learned yesterday with this distributive property. So we know that distributive property is telling us to pass it out to each term. Today, we're going to take that same concept and we're going to build upon it. Okay, so we're going to take each term of the first binomial and multiply it to each term in the second binomial. Okay, so same thing for this. We're going to have to do lots of distributing. Okay, that's going to end up being 4 different pieces that get multiplied by the time we take the first piece and we multiply it to both of them, and the second piece and multiply it to both of them. So if we have something like, you have this section here, we're going to skip it because that's with your algebra tiles. And we're not doing that since you are not in the classroom to do that and you don't have the manipulatives in front of you. So if we are looking at something like 5x plus 6 times 9x plus 2, I'm going to zoom in on that so we can see that a little bit better. Okay, what we are going to be doing with this is we are going to be taking the piece in the first binomial that comes first. So here's our first binomial, and we're going to take the first term. And we are going to ignore the 6. So we're going to take the 5x, and we want to multiply it to all of the 9x plus 2. Okay, we're taking this 5x and we're going to multiply it to each piece in that second binomial, just like we did yesterday. So 5x times 9x is going to give us a 45x squared, right? Those both have an exponent of 1, and when we multiply, we add. Then we'll take 5x times 2, and 5x times 2 will give us a 10x. Okay, then we're going to repeat that process, but now we're going to take the second term in that polynomial, in that first polynomial, in this case binomial. So we're going to take the 6, and we're going to multiply the 6 to both the 9x plus 2. So that 6 is now going to the 9x and to the 2. Okay, so we're doing that distributing process now twice. Since there's 2 terms in front, we are distributing 2 separate times. So we'll say 6x times 9x, okay, will give us a 54x. Now, we could choose to write that 54x anywhere that we want. But if we're repeating this process over here and writing it down, it will be helpful if we rewrite it underneath a like term. So it's not an x squared, but it is an x. So I'm going to put that positive 54x here. That's just my dog. We're going to ignore her. Okay, then we'll take 6 times the 2, which will give us a 12. Okay, once we're there, we can then take these pieces and we want to find any like terms. So if we have any like terms, we can just add them or combine them by using our rule of addition, which we already learned. So 45x squared has nothing that it goes with. We know that 10x and a 54x will give us a 64x. And the 12 has nothing else that it combines with, so it just comes straight down. So our final answer is going to be 45x squared plus 64x plus 12. Now, some of this stuff that I wrote down over here, you can choose to write down every single time, but it's not required to write down every time. We just want to make sure we're getting multiplied to all 4 pieces. So if we look at our next example here, we're going to take our first term and we are going to distribute it to both pieces. So I'm going to ignore that 7, that negative 7, and I'm going to distribute out my 3c. So 3c times 2c will give me a 6c squared. And then I'm going to distribute it to the second term. 3c times negative 11 will give me a negative 33c. Then we're going to flip-flop terms. So now I'm going to start distributing the second term. Now be careful here. We need that sign to come with it. So this is a negative 7. So I'm going to take negative 7 times 2c which will give me a negative 14c. Now, I could write that negative 14c down wherever I wanted. But again, it is a like term with the negative 33c, so I'm going to write it down underneath that. Okay, it's just sort of a little trick that will help it be less work in the long term. Okay, then I'm going to take negative 7 times 11, which will give me a positive 77. Once I do that, I can combine my like terms, right? I already have them nice and neatly stacked. So that will give me a 6c squared minus a 47c plus a 77. Okay, so we look at our next page. Now, when we do this process, you might hear people call this foiling or to foil them. FOIL is sort of like PEMDAS. It's a commonly known acronym. F stands for first, so we multiply the first two of each piece. O stands for outside. I stands for inside. L stands for last. So we are actually doing that pneumatic device every time, but we don't use it as often anymore because it doesn't work on every type of polynomial that you might multiply. But if you do hear that word, it is talking about the same thing. Okay, so if we go through 4u times 3u, I'm distributing that 4u to the first term of the second binomial. I'm ignoring that 9 and taking 4u times 3u, which gives me a 12u squared. Okay, I'm distributing that 4u over here to the second term. So 4u times negative 5 gives me a negative 20u. Now, I'm done distributing that 4u. That 4u and the 9 within the same binomial, those never get multiplied together. All right, now I'm going to the 9, and I'm going to take the 9 times the 3u, which will give me a positive 27u. I'm writing it underneath the negative 20u because those both have the same label, right? I'm not writing it under the u squared because this is a u squared and that is not. And then I'll take 9 times negative 5, which will give me a negative 45. I can combine my like terms by just adding straight down. So it'll give me a 12u squared plus a 7u minus a 45. Now, it's not always the case that we get like terms in the same places. So we can do this process, okay, and not end up with things that stack or that end up in the same place. So for example, if we look at this problem, if we distribute our 7y to the third times our 4y squared, that's going to give us a 28, right? When we multiply, we add y to the fifth. So 3 plus 2 gives me the 5. Okay, then I'm going to go to my next term. 7y to the third times 7 will give me a positive 49y to the third. Now I'm going to go back to my binomial and do the second part of it, the second term. So I'm going to take the negative 10, right? That sign stays with it. Negative 10 times 4y squared gives me a negative 40y squared. And neither of these terms we've already written down are a y squared. So I'm just going to continue this off over here to the side because it's a new column. It doesn't have a matching term. And then finally, negative 10 times 7. That will give me negative 70. There's also not a like term with that. So that's coming over here on the end as well. And there's actually nothing else we can combine because nothing's stacked up. There were no like terms. And so that is, in fact, our final answer, just the way it is. Now, we have what we call some special products, right? Products is multiplication, so some special cases that we multiply with. However, just because they're special doesn't mean any of the rules change. So for example, we call this situation binomial conjugates. The word conjugates means that they look the same, so we'll see the same terms inside, but one is going to have addition and one is going to have subtraction. So if we look at this example right here, right, 10x and 3 are the exact same terms, except one of them has addition and one of them has subtraction. We are going to multiply this under the exact same process. It's just going to have a little bit of a weird thing that happens. So when we take 10x times 10x, we will get 100x squared. Right, we're distributing that 10x first. So I'm taking 10x now to negative 3, which will give me a negative 30x. Okay, so far so good. It's just like normal. Okay, then we will distribute our 3. So 3 times 10x will give me a positive 30x. That's a like term with a negative 30x. And 3 times negative 3 will give me a negative 9. Okay, and at this point you should be going, oh, I see this as a negative and a positive, right? And a negative and a positive just cancel each other out. So a negative 30x plus a 30x will give us 0x. So we don't need to write that down. So we'll just end up with 100x squared minus 9. Okay, and that middle term canceling out will happen anytime that we have conjugates. The last special case that we are going to look at is if we have a binomial squared. And it sounds like exactly what it is. It's a binomial, right? Something with two terms, and it has an exponent of 2. So it is squared. Okay, so we have 8g plus 3 squared. And here is where you really have to remember our rule of what an exponent says, right? This exponent of 2 says to multiply the base times itself. So this whole entire thing is getting that exponent of 2. So it says to multiply that whole entire thing by itself. Okay, this has an addition sign in the inside. That is different than the problems that we looked at where we could just pass that exponent in. This is not a monomial on the inside. It is a binomial. So we have to write that binomial down twice. And once we write it down twice, we then have to go through the entire process, just like we've been doing that distributing twice. So I'm going to take this 8g and I'm going to pass it out. 8g times 8g gives me a 64g squared. 8g times 3 gives me a positive 24g. Okay, then I'm switching terms. So I've already distributed the 8g. Now I'm going to distribute the 3g. 3 times 8g will give me a positive 24g. And 3 times 3 will give me 9. Then we will combine our like terms. So our 64g squared will come straight down. Plus a 48g. Plus a 9.